So hello everyone. In the last session we have seen the concept regarding the capacitor, in which we have seen what is the effect of what is the effect on the different quantities when we are inserting a dielectric at a constant charge and the constant potential. And also we have learned about the dielectric strength, and we have solved some problems, and we have seen what type of question can be asked in the exam. Now in this session we are going to start basically the different combinations of dielectric. What are the different combination of dielectrics are possible? Okay, so I hope you are enjoying this session. So let us start our next topic. This is the different combination of dielectrics. Means how we can fill this dielectric. The different combinations are possible. Let us discuss about these combinations in detail. So let us start with one example. Okay, suppose you consider it a straight line only. Okay, or we can do one more thing. Okay, we have basically partially filled it with the dielectric. Okay, the scene is very different. Initially we have filled it with the completely with the dielectric. Now we are going to see the different combination. So let us consider. Okay, now this is the case. This is the basically your dielectric having a dielectric constant K. Okay, and the distance, this distance you know as it is D. So this thickness is T, means the thickness of the dielectric is T. And suppose area is A is given. My question is that what is the capacitance for this combination? Can you tell me what is the capacitance for this combination? If I have to calculate, so what will be the capacitance for this combination? Can you tell? How will you calculate the capacitance for this combination? See, whenever this type of questions came, you have to go for the very basic. How we will find the capacitance? Sir, capacitance is simply total charge divided by, that is potential difference. That is our capacitance only, sir. We know charge Q is there, you assume it, no issue. Okay, so how will you calculate? Simple thing, sir. If I go by concept, okay, if I go by concept, that is a concept we know. So basically we have to find the potential difference. So let us consider this distance is x. True. Okay, and this distance, then what is this distance? This distance I can say it is t minus d minus t minus x. Correct. So what is the potential difference will be there? The potential difference will be nothing. It will be defined as electric field in this is, what is electric field in this? That is sigma by epsilon naught into what is the distance? That is x, plus what is electric field in this? Sigma by epsilon naught by k. That is a property of a dielectric, into what is the distance? That is t, plus what is the potential difference in this? Sigma by epsilon naught into d minus t minus x. Now what is a common? You can take sigma by epsilon naught as common, and what you will get? X plus t by k, plus what is this thing? T minus t minus x. X will cancel out, and what is the q? So capacitance I can write, sir, q is what? Sigma into a. Q is what? Sigma into a, and this is the potential difference, sigma epsilon naught. This is defined as t by k plus d minus t. Okay, that is a value. So from here sigma sigma will cancel out, and what you will get? You will get epsilon naught a by d minus t plus t by, that is our capacitance for this system. That is our capacitance for this system. Now observe this answer very carefully. What you understand from this answer? First of all, what are the observations we obtain? Okay, what are the observations? That is the important thing. Solving a question is not important. What are the observation you can understand from that question, and then you use that observation in solving the other question in very quick manner. That is the understanding of physics. So what we observe, that the first observation we can made, the answer is independent of x. The answer is independent of x. Independent of x. Clear? Means it does not matter whether you take x, what is the value of x, that is, it doesn't matter. If I keep here also, here also, here also, it doesn't matter, the answer will be remain same. Okay, the answer will remain same. That is the first observation we can make. Okay, so if in second observation what we can make, let us take talk about the second observation. For this I'm just copying this diagram. To make the second observation, I'm just copying this diagram. Okay, here. Okay, I'm just copying this here. So if now what I am trying to ask you for the second observation, just take a look of it. Okay, and if you understand the concept, you can simply tell me the answer. If you have understand the concept, then you can simply tell me the answer. There is a no problem will be there for you if you have understand what I am trying to say. I hope first observation is very clear to you. Okay, now what is the second observation I am trying to make? Let's see here. Okay, okay, now this is the thing. Okay, so this is a configuration is given. Now for this configuration, without using your pen, can you tell me what is the answer? This is plus sigma, this is minus sigma, as it is, or in spite considered it, the charge q is there. Okay, charge q is given here, and minus q will be given here. The area is a, and this distance is again d. Okay, and everything is given. Suppose this is K1, this is T1, this is K2, this is T2, like that. Now for this, can you tell me what is a capacitance now? If you understand this concept, you can directly tell the value, what is the capacitance for this. See, you can take this distance anything, like you can take this as x, this is a y. So what is the distance will become? What is this distance will become? This will become t minus x minus t1 minus y minus t2, correct? Like that you can take. But we know that the answer is independent of x. So I can say the answer will be independent of x and y both. Means it doesn't matter what is the value of x, what is the value of y. So from there we got our observation. If you are able to understand, you can directly write the answer. So what is the observation basically? If you write the answer, if you write the first, let me write the answer for you, then you will understand what is the observation. If you write the answer for this, if you write the capacitance for this, what you will get? You will get epsilon naught A divided by T minus T1 minus T2 plus T1 by K1 plus T2 by K2. That is the capacitance you will get. Basically one extra term will be added here. Simply one extra term will come here. So what we have observed that, we have observed that if there are multiple dielectric slabs are also present there, if there are multiple dielectric slabs are also present there, it doesn't matter, the format of answer will be remain same. That is the second observation we have done. This is the second observation. You can say it is a second observation. Okay, this is the second observation. This is the second observation. So if this is like, if this is going to be happen, then we can write the general formula for this. What is the general formula? The general formula is like this. Suppose I have a the general formula is very simple. Suppose I have a lot of dielectrics slabs are there, and they are partially filled. Like this. They are partially filled like this. Okay, suppose they are partially filled like this. Correct? Like lot of slabs are there and they are partially filled. Suppose this is K1, this thickness is T1, this is K2, this thickness is T2, like this is Kn, this thickness is Tn. Okay, like this. It is going like this. Okay, up to like this. It is filled, and the area of the plate is A, and the distance from this point to this point is D. And the general formula for capacitance C is equal to, remember this, it is epsilon naught A divided by D minus summation from I equal to 1 to n into T of n plus summation from I equal to 1 to n T I to Ki. That is a simple formula for the capacitance for this geometry. So you can apply this formula anywhere. Whenever this type of question came, directly you apply this formula and you will get the capacitance. Simple. Any doubt here? Clear? Any doubt? Clear? Okay. If in this for this configuration only, let me ask you a few things. Okay, let me ask you a few things. First, let me do one thing for you. For this configuration, let me ask you a few questions. Okay, I hope you will answer it correctly. Okay, so this is the general formula which you have to remember. So now let us observe one minute. Okay, yeah. So now let us observe the electric field and potential. Okay, now let us observe how the electric field and potential changes. See, suppose the potential from this plate to this plate is V. Okay, clear? Suppose the potential from this point to this point is V. Correct? First, let us talk about electric field. See, we know that what we know one thing. Whenever we enter into the dielectric, the electric field is reduced by by the factor of K. Okay, so we know that when we enter in dielectric, the electric field reduced by a factor of K. That we know, that is sure, we know that. By using that concept only, if I ask you, by using that thing only, if I ask you, can you draw the graph for the electric field? You draw the graph of the electric field with distance, how that is going to be vary inside this. For this given geometry, for this given configuration, for this given system, can you tell me what is a graph of the electric field? See, here if you talk about here, okay, this is my origin, so I am taking at origin. So what is this distance? Suppose this is x, then t1, then y, like that you can take it. So between, basically there are the different reasons we will have, like this. Are you getting my point? Like this. And so on. Okay, and so on, you can go like this, up to like this. It will be going like this one. Okay, this graph will continue. Okay, so this is the electric field and this is the distance d. Okay, I am talking about distance d, or not distance d, you can take it, write it as some variable. Okay, so in this region, what is the electric field? It is, let E naught is equal to sigma by epsilon naught. So in this region, the electric field is sigma by epsilon naught, correct? So here I will get an electric field as, what is the electric field I will get? Can anyone tell me what is the electric field in this region I will get? I will get E naught, that is sigma by epsilon naught in this region, correct? Now as I come inside this dielectric, it is going to be reduced by a factor of K1. So my electric field is now reduced, it will become like this, it will reduce by a factor K1. Okay, so here my electric field is, here my electric field is E naught, it is here become E naught by K, correct? Now when we are again we are coming in the air only, so in air only again my electric field becomes same like this, which was the initial value. Now if I am coming in this space, again it is going to be reduced, but how much? But how much it is going to be reduced means whether this graph will come down than this or it is greater than this. So for that, let us take K1 is greater than K2, like that, up to Kn, like that you take the relation like this. Okay, if it is like this means my K2 is less than K1, so it will be decrease, but the decrease will be not less than this, so it will be something like this, correct? Like this we are getting the graph, and as so on you can draw. Clear? So here what is my electric field in this region? Here my electric field is E naught. What is here the electric field? This is E naught by K1. What is electric field? Again become E naught. What is electric field here? That is E naught by K2, like this. Are you getting my point? Are you able to understand how I am drawing the electric field? Clear? Any doubt? Any doubt till here? Sorry. I hope you are able to understand what I am trying to say. Are you getting my point? Say yes or no. Okay, so basically this is how our electric field is varying inside this slab, inside this slab, or you can say inside this configuration, how our electric field is varying. So yeah, this is the way how the electric field is varying here. Clear? This is the way how the electric field is varying here. Clear? This is the way how the electric field is going to vary, like this. Clear? Now we know potential is equal to how? Potential is equal to what? We know that potential is equal to dE by dx. Potential is equal to dE by dx, correct? We know this formula, that is potential is equal to dE by dx. We know this thing, so let us use this. Oh sorry, I've written wrong. This is not dE by dx, sorry. This is minus times of integral E dot dx, correct? Clear? Now I want to plot the graph for the potential. Okay, now here if you see, the electric field is constant. If E is constant, if my E is constant, and if you are integrating a constant function, so my delta V will be what? Delta V will be, means E is constant, I can take it outside, correct? For a particular reason, suppose I am talking about this reason, E is constant, I can take outside, I can integrate dx. Okay, it will be something came as a function of x, correct? Like dx I will integrate. So let us take, suppose I am integrating from here to here, like that. So it will be something from x1 to x2 I will integrate, correct? So this will become my x2 minus x1, correct, is equal to delta V. So I can say, what I can say, that this function is going to be a linear function with negative slope, correct? The slope is going to be negative, it is not going to be a positive. That is the thing we can say from here. It is going to be a means what we have obtained, the electric field graph is, the potential graph is going to be a negative slope having a linear function, correct? Any doubt till here? It is going to be a linear function with a negative slope. That is the thing, sir, we have obtained. So if you have obtained this thing, can you tell me one more thing? Okay, what, sir? As my k1 is greater than k2 is greater than k3 dot 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 kn. I am teaching you very slowly this topic because this topic is very important. Okay, for advanced point of view, this is very important. They have lot of time, they have asked a question on the graph. Till here it is clear. Now k1 is less than k2 is less than k3 is less than like this. So what is basically going to be the, see, this is what, this is the electric field. So if I am talking about slope, what is the slope from here? Can you tell me what is the slope from here? So the slope is nothing but it is minus e. The slope is minus e. Okay, the slope is minus e, sir. Okay, no problem. The slope is minus e, sir. So let us forget about negative sign. Just consider the magnitude. So let us consider the magnitude. So slope magnitude is basically we can say the magnitude of the slope. Magnitude of slope. What is the magnitude of slope? Magnitude of slope is E. Correct. I am talking about the magnitude of the slope. Now in the first reason air, what is the electric field? E naught. Correct. In the second reason, what is the electric field? E naught by K1. The third reason, what is the electric field? E naught. Again, then E naught by K2. Like this. Clear? Clear? Any doubt? Okay. If it is like this, now you tell me the one thing. This value is lower than this or greater than this? Which value? I am comparing these two values. I can say, sir, my E2 by K2, this value is basically greater than E0 by K1. Correct? Means what is going to be happen? This slope will fall very fast as compared to this slope. Okay, because this is a slope now. So this slope means this will fall very fast and this will fall very slow. Correct? Means the falling of the slope will be very fast in this case, whereas it is slow in this case. Are you getting my? First digest that point. First digest that point, then we will understand. Okay, then you will understand what I am trying to say. See, if you talk about this thing is less. Okay, that is slope is less. That means it will be straight like this. Slope is less. Okay, sorry. Yeah, slope is less, so it is straight like this. But in this case, the slope is more, so it will be fall very fast. So the slope will be more like this. Okay, the angle will be more. Are you getting my point? Are you getting my point? Okay. So if I draw the graph, basically what I am trying to say, suppose I am falling with this slope. So with this slope, you can see this slope is less. So that means that it is something like this. Okay. Take it as y-axis and this is as x-axis. The slope is something like this or something like this. The angle is very small. Now what I am trying to say, for this the slope is more. That means the angle is more. So it is something like this. Are you getting my point? So you can see the slope is more and the angle, this angle is small. This angle is small. See this angle. Okay. Let me try to explain you in better way. See, for this case, the slope is less. Okay. And this angle is theta 1, suppose. Now for this case, the slope is more. That means this angle is theta 2. So I can say one thing. So the theta 2 will be less than theta 1, yes or no? First you identify this point. Theta 2 will be less than theta 1. This you have to understand. Okay, this is a mathematics. You have to understand this. This is the mathematics. So if you have able to understand, then can we draw the graph? Yes, now we can draw the graph. See how we can draw the graph. Okay, if you have understand this, then we can draw the graph very easily. Let us see how. Hmm. Hmm. So now if I want to draw the graph, I can draw it very simply. You can see now. So as we go from here to here, my electric field is going to decrease like this, correct? Sorry, potential is going to decrease. I'm talking about potential versus x, okay? And obviously this value will be less than this value, correct? Means the slope will be less, okay? So again it will fall. Let me draw it properly, because again it is going to fall, correct? Now here in this case, when it's come to k2, the slope is very like very, it's fall very drastically, okay? So if you talk about these angles, what I am trying to talk, suppose this angle is theta 2, sorry, theta 1, theta 2, theta 3. So we will see that my theta 3 is less than theta 2 is less than theta 1. That is the what it is. In diagram maybe it don't look like, but in reality it is like that only, okay? Theta 3 is less than theta 2 is less than theta 1. In diagram it doesn't look like, because I haven't drawn it properly, but yeah, in reality if you draw, you will look like this only. Let me draw it properly. Doesn't look like this, okay? Theta 1, theta 2, theta 3, okay? So this is the graph of potential you will get, okay? It's again not coming proper, wait. I hope somewhat it came, but yeah, this is the graph you are going to get it. Okay, sorry, there is a air na. Okay, air means again this graph, this slope is going to decrease or increase. It will increase. So the graph will be something like this. Theta 3. So will be, if you find the relation, so I can say my theta 2 is less than theta 1, and also my theta 3 is greater than theta 2. This is the two relations we can observe. Clear? That is what we observed. This is the analysis you have to understand regarding the potential and the electric field. And what the basically the question they have asked, what they have given, they have given this. They have said that here we have filled K1 and here we have filled, let me tell you on the different page. On this concept only they have asked a question. What I told you the concept right now, na? This concept of this thing. On the same thing, J Advance have asked one question. What is the question? They have asked that Suppose we have a two dielectrics are filled. This is K1, this is K2, and they have given a graph like this. From here, then from here. This angle is theta 2 and this angle is theta 1. From here we can say theta 1 is greater than theta 2. So what can you comment about K1 and K2? K1 is greater than K2 or K2 is less than K1, which is true. See, one thing is very clear. If this angle is more than this, that means this slope is less. So this slope is less, this slope is more. This slope is more, that means that K2 is what? K2 is less than K1, simple. K2 is less than K1, like that. So that is why I told you that concept, because it is very important for you to understand those concepts, because they have asked a question on this concept. You have to understand how the theta and how the slopes are changing with respect to the electric field. Okay, for the potential, that's why the potential is more important as compared to the electric field, because electric field anyone can draw, but potential you have to understand it very properly. Clear? If it is clear, please note it down. So this is the formula, this is the graph of potential electric field, complete PhD. We have done a complete PhD on this. Okay, I hope there is no doubt. Clear? Okay. Okay, now let us move to the most easy portion. I am going to give you some configuration and I am going to ask you what is the C net for that system. The question is very simple. You have to calculate the C net. Okay, I am going to give you some configurations. So first configuration is given is like this. Suppose I have this and I filled it with a one material as K1 and with another material as K2. My question is very simple. What is C net for this? Clear? What is the C net for this? And my second example. Solve it, solve it. Tell me what is the C net for this. Suppose this is K1. This is filled with K2. Again my same question, what is C net? Okay. Clear? See this, 1 minute, just a minute. Okay. Okay, tell me. Calculate and tell me what is the C net for this. How will you calculate? See, just what you have to do, simply break it into a two different capacitor. If you see, this is my capacitor C1 and this is my capacitor C2. C1 and C2, they are connected in series or parallel? They are connected in series. So what is C1? I will write. The C1 is very simple. It is epsilon naught A. A is area and D by 2. Correct? This is D total D is D by 2, D by 2. Okay? Into K1. Then C2 is what, sir? That is epsilon naught A D by 2 into K2. And they both are connected in series. So what is my C equivalent? C net is equal to 1 upon C1, that is D by 2 into K1 divided by epsilon naught into A plus D by 2 into K2 divided by epsilon naught into A. So from here you can get my what is the C net? C net will be epsilon naught A D by 2 bracket K1 plus K2. Simple. Clear? So you can get one observation in series. The K1 K2 will added up together. Now here in parallel, they are parallelly connected, correct? So what is my C1? You can take it as C1 and this is as C2. What is C1? That is epsilon naught A by 2 divided by D into K1. And what is my C2? C2 is epsilon naught A by 2 into K2 divided by D. Correct? You can draw it. You can, if you have a confusion, you can draw like this. So this is a one capacitor, this is another capacitor, they are connected in parallel. Correct? You can draw like this. That is not a big problem for you. Okay? Now just it is a parallel combination, so C1 plus C2 is CNET, which is equal to epsilon naught A by 2D in bracket K1 plus K2. Simple. Any doubt? Clear? Like this. So let us take some more example. So let us take suppose this is filled with K1, this is filled with K2, and this is filled with K3. Again, my same question, what is CNET? Tell me what is the CNET value? Solve it and tell me fast. Okay, what is CNET for this? Simple. This is my one capacitance C1, this is my another capacitance C2, this is my another capacitance C3. How will you draw this? How will you draw this? Sir, we can see one capacitor, these two capacitors are in parallel or series. They are in series, and the combination of these two is parallel with this thing. Clear? This is C1, C2 and C3. Now calculate what is C1, you know, that is epsilon naught. Area is A by 2, distance is also D by 2, and this is K1. Then C2 is equal to epsilon naught A by 2 D by 2 into K2. What is C3? Epsilon naught. The area is A by 2 into K3 divided by D. Now C1, C2, C3, you know, just apply this. C1 is series with C2. In series, what we have seen, what is my, see, this 2 by 2 will cancel out. So what is C1 plus C2 you will get? Sorry, not C1 plus C2. Basically, what is C1 parallel with C2 plus C3? That is my CNET. That is the answer. Okay. Now you do the C1 parallel with C2 and plus C3. Simple. Just what you have to do, you have to simply break into the different combinations. Clear? Any doubt? Okay. Any doubt here? No. Okay. Let us take one more example. Suppose this is filled with K1, this is filled with K2, K3, K4. My question is not to calculate C1, but my question is that whether this will be treated as like this, C1, C2, C3, C4. This is C1, this is C2, this is C3, this is C4, or is something like this. C1, C2, sorry, C1, C3, C2, C4. Okay, I want to know which one is correct. This one is correct or this one is correct. Whether you will break it in this form or you will break it in this form. Which one is correct? Are you getting my point? I want to know like which. I hope it is not visible to you. Let Okay, so I hope it is visible to you. Yeah, so which one is correct? This one is correct or this one is correct? I want to know from you which one is correct, whether we will take this configuration or that configuration. Which one we will take, this one or this one? How many of you saying this one? See, this is wrong. First of all, this is wrong. Why it is wrong? See, when you are taking this configuration, what you are doing basically, you are considering that this point, this whole point is at equipotential. Means this whole the potential at this point and potential at this point is same. So if you see, this point is nothing but this thing. Okay, can you show me the potential here is same on this line? The potential is same. Answer is no. Sir, how the potential is different? Because this is a different material, the potential will be different. Here the potential will be something A1, something with respect to K1, K2. Obviously the potential is not same. If you draw the graph also, you will not get the same potential at this interface. Correct? But here you are assuming that here the potential is same at this interface, but it is not true now. That means this is wrong. This is the correct configuration. So you have to draw this configuration and then you have to calculate. Why I have told you this question? Basically, one time in previous year there is a one question has came, and this question is like this. They have given this question. They have given like this. They have given this is K1, this is K2, and this is K3, complete K3. Now they ask the CNET. So what a student have done, they have taken this as parallel and then with the series. That is wrong. First of all, what you have to do to solve this? What is the steps you have to do? You can't take these two as series, these two as parallel and then take it series with this. You can't do that. That is wrong. That is a completely wrong method. What you have to do? You have to first break this into an equal part. Okay? Then in that case, you will get one C1, one C2, one C3, one C4, and then you have to apply this. This is C1, this is C2, this is C4, this is C3. Then you have to apply this. That is the correct step of solving this. This is the previous year question. And the concept behind this is the concept. You can't break. Many people what the people has done in the exam, they have taken these two and the parallel and then they have taken the series with this. That is completely wrong. And some people what have did, they have taken this, they have broken into the equal part, but they have taken this configuration. That is also wrong. What you have to do, you have to first break it into the equal part and then you have to take this configuration. Means what I will write C1, my C1 will be how much? C1 will be, sir, epsilon naught A by 2 into K1 divided by D by 2, sorry. Then my C2 will be, sir, epsilon naught A by 2 K3 divided by D by 2. Similarly, sir, my C3 will be, sir, epsilon naught A by 2, that is K2 divided by D by 2. And what is my, sorry, this is my, I think I have written K3 here. Okay, so this will become my K3. And similarly, C4 will be, sir, epsilon naught A by 2 and K2 divided by D by 2. So that is C1, C2, C3 you have to write and then you have to apply this. Then you have to apply this. Are you getting my point? Till here, everything is clear? Okay, so this is what you have to follow for this question. Clear? So I have given you a complete PhD on the dielectrics. Okay, this is the complete PhD of the dielectric. Okay, beyond this, anything cannot be asked in the dielectric. Now this is a complete PhD on the dielectric. I have given you the complete PhD at your level. Okay, there are a lot of things, but at your level, this is the complete PhD. Okay, beyond this, I don't think so any institute or anyone will teach beyond this, because this all the concepts which are present in the combinations of the dielectric. Clear? Now in the next session, we will try to start the variable capacitor. Means variable capacitor means when we are filling with a variable dielectric constant, then in that case how to calculate the capacitance, and then we will see the spherical and the cylindrical capacitor. I hope that our next session going to be the last session. I hope you have enjoyed this session also and you have learned a lot of new things. Till then, take care, goodbye, and if you like this session, please like it, share it and subscribe it. Have a nice day. Thank you.